Section 6.6 is more trigonometric graphs. Basically, these are the rest of the trigonometric graphs. And unfortunately, when we did the sine and cosine graphs, I was able to have you graph the sine and then graph the A and see what that did, and graph the B and see what that did. There's really no easy way to have you explore these graphs on their own. So unfortunately, I'm just going to kind of go through and tell you about the other four trig functions. So to begin with, the period of the tangent function is pi. Because the tangent graph is a ratio of sine over the cosine, every time the cosine graph is 0, there's going to be an asymptote on the tangent graph. The cosine is 0 every odd pi over 2, so there's going to be a asymptote on the tangent graph for every odd pi over 2. What I mean by that is negative 3 pi over 2, negative 3 is odd, but negative 2 pi over 2 would be an even, but that would be a whole pi. So negative 3 pi over 2, negative pi over 2, positive pi over 2, positive 3 pi over 2. We can keep going with that. It's going to cross the x-axis every time the sine graph, because again it's a ratio of sine over cosine, so every time the sine graph is 0, it's going to cross the x-axis. The tangent graph will also be 0. That's going to occur at every whole pi. There I have put a dot at every whole pi. That's where the tangent graph is going to cross the x-axis. The amplitude, this is a little bit harder to understand and see. So in this first graph, the way you're going to graph the amplitude, basically halfway between the 0 and the asymptote is going to be your amplitude. So this has a base graph of 1 is the amplitude, so every 1. So then it's going to be negative 1 and positive 1. So I'm just going to put those dots there. And then the tangent graph is kind of like a swoop. So between each of these asymptotes, this is what your tangent graph is going to look like. Now putting all that together, again, the A is still the amplitude, just like it was with the sine and cosine graphs. It's the steepness. The period, instead of being like the sine and cosine graph of every 2 pi, the tangent graph has a period every pi. So to find the period of a transformed graph, you would take pi over b. The phase shift is still your negative c over b. Again, you find it by setting bx plus c equal to 0. And then the way you find those successive vertical asymptotes is by putting that same bx plus c as an inequality between negative pi over 2 and pi over 2, and then solving that for x. Just make sure that you remember that whatever you do in a compound inequality, whatever you do in the middle to get that x by itself, you need to do to both ends. Now let's take a look at what all this means with the cotangent graph and what the base cotangent graph looks like. Again, similar to the cotangent graph, A is still going to be your amplitude. Your period is still going to be pi over b. But now remember, with the cotangent graph, you have the sine on the denominator. So whenever the sine is equal to 0 is whenever you're going to have your asymptotes. So again, you're going to set that bx plus c as a compound inequality between 0 and pi. And it's going to cross the x-axis every time this cosine graph is equal to 0, which is going to be every odd pi over 2. So putting all of that together, this is going to be what your cotangent parent graph is going to look like. Now let's look at the cosecant graph. Remember that the cosecant graph is 1 over the sine. So I'd like you to pause the video and look at either the notes or this picture on the video and name a couple things that you notice about this graph. Hopefully one of the things you noticed is that dashed graph, so the cosecant graph is based off of the sine graph because it is 1 over sine. So that dashed graph is the sine of x graph. There's also asymptotes, where the sine of x graph crosses the x-axis. And if you think about this again, the cosecant is 1 over the sine, and where it crosses the x-axis, the sine is 0, so it's going to be undefined there. And then finally, the cosecant graph touches the sine graph at its peaks and valleys, and then continues to use those asymptotes to guide how it extends upward or downward. Now with the secant graph, again, the secant is 1 over the cosine, so you're going to have the same similar relationships. It's just going to be in relation to that base cosine graph as opposed to the base sine graph. So now how do we go ahead and graph these transformations of cosecant and secant graph? The first thing you're going to do is replace the cosecant with sine, if it's a cosecant you're graphing, or secant with the cosine. Now instead of having an equation with a cosecant, you're going to have an equation with sine that you would need to graph, or cosine, and you're just going to graph that sine or cosine graph as you had previously when we graphed those transformations. After you've graphed that sine or cosine graph, then you're going to draw the asymptotes where that sine or cosine graph crosses the x-axis. And then finally, you're going to use the asymptotes and the peaks or valleys of that sine or cosine graph to sketch in your cosecant or secant graph, whichever one you're working on. So now let's go ahead and try to do an example. Again, as I always do, I would challenge you to turn off the video and try to graph this on your own. First thing we need to do is determine the amplitude, the period, and the vertical asymptotes. Well, our amplitude is 1/2. Our period is pi over b, but in this case our b is 1, so it's simply going to be pi. And then our vertical asymptotes, remember we need to set up that compound inequality. So again, pause the video, go ahead and do that. When we solve for the vertical asymptotes, we find that they are at -3 pi over 4 and pi over 4. And again, this is kind of a good check, because if you notice, what's the distance between -3/4 pi and a positive 1/4 pi should be the same as your period, which is pi. Go ahead and graph those asymptotes along the whole graph now, please. Now we've got our asymptotes drawn. Then remember that the tangent graph is going to cross the x-axis halfway in between each of those asymptotes. So I'm going to mark that point. And then halfway between where it crosses the x-axis and the asymptote is where you're going to graph the amplitude. My amplitude is 1/2. So I'm going to graph my amplitude, positive and negative 1/2. Remember, it's going to be positive or negative depending on the quadrant we're in. After I get those 3 points graphed, and with the help of my asymptotes, I can draw in the tangent swoop. And there you have the 1/2 the tangent of x plus pi over 4. Now again, I challenge you to pause the graph and graph y equals 2 times the cotangent of x plus pi over 2. Before we start, we need to figure some of these things out. So our amplitude is that 2. Our period still is pi over b, and our b is still 1, so my period is also going to be pi. And then remember, my sine is on the bottom, so I'm going to set up this compound inequality of 0 is less than x plus pi over 2 is less than pi. Then go ahead and solve that, and we get x is less than negative pi over 2. Sorry, x is greater than negative pi over 2, and x is less than positive pi over 2. Go ahead and graph those asymptotes in and see if you can graph the rest of your cotangent graph. So there I have my asymptotes drawn. Halfway between the asymptotes is where it crosses the x-axis. And then I need to graph in my amplitude of 2. So I have those points graphed in. And because of the relationship of this graph, it's going to look like a straight line, but do your best to kind of draw in a swoop. And now let's finish this up with a cosecant graph. So again, first we're going to replace the cosecant with sine. So y equals 3 times the sine of 2x plus pi. And now we're just going to go ahead and graph that graph before we worry about the cosecant graph. So again, write down your amplitude, your period, your phase shift. My amplitude is 3. My period is 2 pi over b. In this case, my b is 2. So 2 pi over 2 is going to be pi. And then my phase shift, when I set 2x plus pi equal to 0, and I solve this, I get x equals negative pi over 2. So my phase shift is going to be negative pi over 2. Remember, the first thing you're going to graph now is y equals 3 times the sine of 2x. So I would recommend doing that first of all in like a dashed pencil. So there in very light pencil, you can see I've graphed y equals 3 times the sine of 2x. Now we need to phase shift that pi over 2 units to the left. Now there in the blue dashed, you can see I have the full sine y equals 3 times the sine of 2x plus pi graphed. Now we need to draw in the asymptotes and sketch in the cosecant curve using the peaks and valleys and asymptotes. And there, that pink graph is the final cosecant graph. Y equals 3 times the cosecant of 2x plus pi. Please make sure you come to class. If you have any questions, we can do a few more of these examples. I'll see you then.